Ocean Avenue, where I used to sit.
Hey, what's up, guys? So this video deals with graphing linear inequalities. All right. So if we think back to when we solve inequalities, so you're gonna have something where it's 3x plus 2 is less than or equal to I don't know, let's say 11. All right. So the steps you're going to solve to the steps you're going to do to solve this are the same old steps you're going to do to solve any equation. You want to get your x variable by itself, so you subtract 2 from both sides. We get 3x equals 9. Divide by 3, and we get x is less than or equal to 3. All right. Now, the way you finish off a problem when you solve an inequality, you must graph it on a number line. All right. I have a reason why I'm doing this, and it'll make sense in a little bit. So we grab our number line. We find out our main number we care about is a 3. So that's why it's in the middle. Since we're talking about x being less than or equal to, we're allowed to involve 3 in our answer. So we're going to put a closed circle around 3. We need to think of which number is less than 3, because that's what x is. X is less than 3. Is 2 or 4 less than? 2 is less than. So we're just going to shade to the left, right? And that's how you solve your inequality. And you must finish it by graphing a number on the number line. Now, the same idea happens or goes when we're graphing a linear inequality, or basically linear inequality. So what I'm going to do is, before I graph a linear inequality, again, I'm just going to graph a linear equation. So let's say we have y equals, I don't know, negative 2x minus 3. So if we were going to graph this, since it's in y equals mx plus b form, our b is negative 3, which is our y-intercept. So I'm going to go down to negative 3, make a dot, make a point. Our slope is negative 2 over 1. So from this point, I'm going to go down 2, over 1, down 2, over 1, down 2, over 1. And we would connect our line. All right? And that would be it. Same thing, when you solve an equation, or when you solve an inequality, solving an inequality are the same steps to solving an equation, except there's a little extra at the end. Same thing goes when you graph linear inequalities. You graph the line, like we've always done, and there's a little bit at the end. What I mean by there's a little bit at the end is this. So what I'm going to do is, I'm going to erase our line. All right. I'm going to graph the same line, but instead of it being equals to, let's say greater than or equal to. So again, we're going to graph it the same exact way, because it's still y, mx, and b. So again, our b is down here at negative 3. We're going to go down negative 2 over 1, since that's our slope. All right, and I'll go back to b, go up 2 to the left 1, oops, up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. And again, the only real difference now is before we make our line, right, we must think of, what does this inequality symbol mean? It's saying y is greater than or equal to. If you think back to when you solve a linear inequality, you must first find out if there's an equals to here. You put a solid dot on the 3. Same thing goes when you're graphing a linear inequality. If there's any equals to in the symbol here, your line is going to be solid. So you're going to graph it just like you always have. All right? That's your first step. That's different. The second step, if you remember, when you solve a linear inequality, after you figure out if your circle is going to be open or closed, you must know, are you going to shade to the left or to the right? The way you do that is you test a point. So if we test the number 2, we put 2 is less than or equal to 3. That's a true statement, so we're going to shade to the left. All right? Same thing goes for a linear inequality, except since we're on a graph, we're not really going to be able to shade a point. We're only going to be able to shade part of our graph. So instead of testing a point, on graphs you use coordinates. All right? What you can do is pick any point on your graph that does not go through the line. The general rule of thumb is, as long as your line does not go through the origin, or 0, 0, test that point, because 0 is the easiest number to work with. So I'm going to test the coordinate 0, 0, and I'm just going to substitute them in. So 0 in for y. Oops. So 0 is less than or greater than or equal to -2 times 0 minus 3. That cancels. You get 0 is greater than or equal to -3. And we think, hey, that's a true statement. 0 is greater than or equal to -3. So now we're going to go on our graph, and let's put a point where 0, 0 is. Okay. Now, just like when we graph or when we solve a inequality, we must shade everything on that side of 3. Everything on this side of the line, we're going to shade because that made it a true statement. All right. So everything over here is what we're going to shade. So our final answer for this problem is not only our line, but also our blue shaded area. So this is our entire solution. You must understand that just like when you graph an inequality on a number line, you must have the correct shaded or solid circle, and your shading must be correct. Same thing here. Your line either has to be solid, or we're going to find out how it can change in the next one, and you have to have your correct shaded, whether it's above the line or below the line. And really that's it. So there's really only one extra step when we graph them, and that's that you have to figure out what kind of line you're going to have and where you're going to shade. All right? And I hope that kind of just makes it simple because it really is not any more challenging than that. So again, let's try another one. Let's say y is less than -2/5 x plus 5. Again, we have y is less than -2/5 x plus 5. So we're going to graph it just like you do any other equation or inequality in y because mx plus b. You say you find out your b is 5, so we're going to go on our y-axis, go up 1, 2, 3, 4, 5, put our first point. Then we're going to do our slope, which is a -2/5. So we're going to go from our y-intercept down to the right 5, down to the right 5. Wait, 1, 2, 3, 4. Okay, we're good. So I can go up to the left 5. 1, 2, 3, 4, 5. All right. Now, if we notice here, our inequality symbol just says less than. So say you had x is less than 4. When you draw your number line, 4 is going to be in the middle of it. There's 3 there. There's a 5 there. If you remember correctly, on 4, since there's no equality here, it's just less than or greater than, there's going to be an open circle on 4. Now, when you graph a line, you can't really have an open line because then you wouldn't have a line. But what we can do is instead of having a solid line, you're just going to have a dotted line go through your points. All right? So that's the equivalent of having an open circle for graphing a linear inequality. Instead of having a solid line, like we did on this one, because it was greater than or equal to, if it's just less than or it's just greater than, you're going to have a dotted line. And again, once you figure out your line, you must test your point. This line does not go through 0, 0. All right, so let's test that. 0 is less than -2/5 times 0 plus 5. Cancels out. 0 is less than 5. Is that a true statement? Of course it is. So since our test point was below the line and it made a true statement, we're going to shade below the line. And that's really all there is to it. It's nothing too crazy. That's about it. All right. I'll do one more just so we can test it out. But again, this is your final answer. You graph the line, same way you graph any line. Y-intercept, use your slope. Then you have to see, is there any type of equality in this symbol? If there is, you're going to have a solid line. If there's not, you're going to have a dotted line. Then you figure out a test point. Like I said, always pick 0, 0 if you can. Okay? In the next example, you won't be able to, and I'll explain what you do then, and it's very simple. But if that test point creates your inequality to be true, you shade on whatever side the test point's on. If it doesn't make it true, shade on the opposite side. So let's try one more, just so we can cover all the bases. All right, so we're going to go here. Our equation, let's make it y is greater than, actually, I'm going to do less than 2x. All right. So again, the first thing you always do is graph this. It's y equals mx plus b. If you notice, there's no constant term. There's no plus or minus number. So really, there's a plus 0. And a lot of kids forget this. So your y-intercept is actually at your origin of 0, 0. Okay. And again, our slope is negative 2, which is negative 2 over 1. So from our first point at the origin, we go down 2 over 1, down 2 over 1. Go back and go up 2 over 1, up 2 to the left 1. All right. So that's the first step. You plot some points. Then we got to look. Our inequality symbol. Is there any equality in it? The answer is no, because it's not equals to. It's just y is less than negative 2x. So since there's no equality, we're going to have a dotted line. All right. So it's a dotted line. Now, like in the last two problems, we tested the origin to be our test point. However, that's because neither of our lines went through the origin. Well, the trouble here is that a line does go through the origin. So all you have to do is pick another test point. If I were you, pick a test point that's really easy. So I'm going to pick this right here, 1, 1. All right. So the test point is 1, 1. All you do is substitute those in. So there's a 1 for y is less than negative 2 times 1, which says 1 is less than negative 2. Is this a true statement? Is 1 less than negative 2? No, that's wrong. That's not right. Not a true statement. Our test point is above the line. That gave us a false inequality, so you're going to jump and shade on the opposite side. Okay? Our test point was false because 1 is not less than negative 2. So instead of shading on the side of your test point, we shade on the other side of the equation. I mean, of the graph. All right? And that's really it. The steps to solve or to graphing an inequality is you need to first graph the line, then check and see is it a dotted or solid line. Then you pick a test point. If it's a true statement, you shade on that side of the line. If it's a false statement, you shade on the other side of the line. All right. Other than that, there's nothing else to it. A lot of kids have trouble with this because they just forget how to graph, and forgetting how to graph is something very simple to correct. It's just practice. So if you have any questions, check out Derivative Dude. If you forget how to graph, there's a whole video on graphing linear equations back in some of the last topics. So if you have any questions, email me. Check out the rest of the site. Have a good one.